term operations to make numbers non-negative. So for this problem, we are giving an array nums, and we are also giving two values x and y. And you need to be careful about this x and y. Actually, y should less than x. Otherwise, you may not think about how to solve the problem. This is very important. This means x is always bigger than the value of y. And there are actually two steps of one operation. The first step is decrement nums I by x. So for example, we can choose this 7. We're gonna decrease 7 by 4. That is the first step. And then we're gonna minus all the elements by 2 except this 7. So currently, let me just copy the array and do some operations like this. So the first operation is just 3, 4. It's the same. So 3, 4, same, 1, same, but 7 becomes 3 because 7 minus 4, and here is 6. And then all the elements will minus 2 except that 7. So here gonna be 1, 2, 4 minus 2, and minus 1, and 3 minus 2. 3 don't need to minus because it has already minus 4. 7 minus 4 equal to 3, so we will keep it 3. And the last one, 6 minus 2, it's gonna be 4. So this is actually the first operation. There are two steps. And then we're gonna continue. So we're gonna continue from here. From here. So we're gonna choose maybe the biggest number. So for this 4, we're gonna minus 4, it's gonna be 0. And others will be minus 2. So it's gonna be minus 1, 0, minus 3, 1, and here gonna be 0 because this element will minus 4. So this is like the straightforward way of doing the problem. So if we find a bigger number, we're gonna always minus x, and except x for all other elements, we're gonna minus 2. We're gonna minus a smaller number. So this is the second step, and then let's go to the third step. So we're gonna choose the maximum element. So for others it is okay, minus 1 okay, 0 okay, minus 3 okay. This one, minus 4, it's gonna be minus 3, and then gonna be 0. Now we don't need to do minus 2, but even if we do it, it is still okay. If we minus 2, minus 3, minus 2, and minus 5, here gonna be minus 2. So in this way, all the elements will be less than or equal to 0. So how many steps? There are gonna be 3 steps. But as you can see, this is the O(n) squared times complexity. It is not okay because n is 10 to the power of 5. This means we need to optimize the algorithm to let it run faster. So one method gonna be n log n time maybe. So how can we solve it in n log n time? We need to check the array carefully. So actually there are two steps. The first step, all the elements, we're gonna choose one element will minus x, and for all other elements will minus y. So for minus x, we're gonna choose the element maybe nums I. Nums I will minus x. So we're gonna choose one element, nums I will minus x, and all others will minus y. So actually these two steps can become other two steps, maybe easier to solve the problems. So all other elements will minus y. So what about we change these two steps to another two steps? Let's say, what about if we minus all elements by y, minus all numbers by y? If we minus all elements by y, why we gonna change to this? Because this is easier to calculate. And then because this element should belong to x, now it has a value of minus y, but actually this element just needs to minus x. Yeah, so this means we need to choose one element nums I, and this element will minus a value of x minus y. Yeah, you need to turn those two lines to these two lines, then you can solve the problem. Why? Yeah, because if you minus all the numbers by y, so there must be one number which you need to find. For example, maybe this is the biggest number, it is the nums I minus y, but actually you need to keep it minus nums I minus x. How can you keep that? You just need to use this number. Yeah, minus x minus y. So what is it gonna be? Let me put it here. Yeah. So we have this number minus x minus y. What is it gonna be? It's gonna be equal to nums I minus y minus x plus y. So it's gonna be minus x. Yeah. Now you see, because you want to get nums I minus x, now from those two operations you can still get nums I minus x. Yeah, it is the same, but the calculation would be much easier because all the elements minus y, you don't need to check one by one. You just need to do one operation. It just takes all one time. Yeah, this will be much faster. And then you're gonna choose all other elements one by one until you find a solution. Yeah. Let me just use this array as an example to do the operations by those two lines. Yeah. So we're gonna use a binary search to check this problem, because if we guess a value, for example, if we guess a value maybe 3 is the answer. Let's just guess a value of 3 to check if it works. First of all, we're gonna let's guess a value of 3. Let me put it here. Yeah, we're gonna guess a value of 3 to check if it works. So first step, let's do the first step. All the numbers will minus y, and how many times? So there are 3 times. So it means y is 2. 2 times 3. So all the elements will minus 6. Yeah, let's just check it. So inside 3 minus 6 minus 3, 4 minus 6 minus 2, and 1 minus 6 minus 5, 7 minus 6, it is 1, 6 minus 6, it is 0. So this is all the operations we did. All the numbers will, by y. So this means all the numbers will minus y, and there are 3 operations, so it's gonna minus 6. Yeah, and then we're gonna do the second operation. So we're gonna choose a nums I, and this nums I will minus x minus y. And which one we're gonna choose? Yeah, we're gonna choose the numbers which is more than 0. If it is less than 0, we don't need to do it. So we just need to check this number. It is more than 0. Yeah, so for the operation of 1 minus this number. So how many operations? It is only one operation, right? But how can we do it? We're gonna use a cell in Python. So cell of 1, this element, minus x minus y. X is 4 minus y2. It is it is 4 minus 2. So it is 1 divided by 2, but we choose a cell, so it's gonna become 1. Yeah, so it means it is one operation. But this one operation is less than 3, because in total we need 3 operations. So it means this is true. At least this 3 gonna be true. If it is true, maybe we're gonna guess let's check. We're gonna return the minimum value. We're gonna guess a number of 2 to check if it is possible, and by applying 2 into the algorithm, 2 is not possible, so it means it is 3. Yeah. Now let's just write the code. So for binary search, let's just prepare the template. Normally we need 1% of the time preparing for a template and 99% of the time practicing this template. Yeah, because there are so many tricks. In this example, there are so many. This trick is just needed to combine those two lines to another two line by mathematics calculation. Yeah. So the L should be 0 and R should be 10 to the power of 9. And the result would be 0. Why R equals to 10 to the power of 9? This is according to the constraints, because nums I is in the range of 10 to the power of 9, and Y and X is also in the range. Yeah, if we choose a minimum value X minus Y, because X is always more than Y, so X minus Y, the minimum value is 1. So, but the nums I gonna be 10 to the power of 9. So how many operations we can get it to 0? It is 10 to the power of 9 operations. So this is why we're gonna choose R to be 10 to the power of 9. Yeah, if you don't know how to calculate, maybe you're gonna guess a very big value, 10 to the power of 19. It's a really big value. I think it should also work. Yeah. Now let's just start the template of a binary search first. Yeah, L less than R. We're gonna get a M should equal to L plus R minus L undivided 2. And I'm gonna use a check function. If check this M value, if it is okay, so it means R should equal to M minus 1. Yeah, but before that, I need to record my result. So result should equal to M. Yeah. Otherwise, so L should equal to M plus 1. We're gonna guess a bigger value. Yeah. And finally, we're gonna return the result. Yeah. Now let's go to the hard part of the problem. It's gonna be the check function. Normally, I'm gonna put a threshold inside as all my operations. So I'm gonna prepare an array. So this array will do the first operation. The first operation is just I'm gonna choose a number n minus this number y times the threshold. Yeah. So for n in nums. So this is my first operation. I will choose all the elements minus y times the threshold, just to check if all the elements is okay or not. If it is not, I'm gonna do the second operation. So for n inside array, yeah, I'm gonna use a counter to check if this count is less than and equal to the threshold. Count would be equal to 0. Yeah. So count, I'm gonna check this n. If this is more than 0, I'm gonna count it. So count should plus equal to, here I'm gonna use a ceil with this n and divided by x minus y. Yeah, I've already explained it. Yeah, I hope you understand. And finally, we just need to return if this count is less than or equal to the threshold. Yeah, so this is the entire code. As you see, it is not long enough. Yeah, the code is really easy, but it's really difficult to think about those two lines. How can you combine to one line? So you have to practice, and then maybe you're gonna find a way of solving this kind of a problem. Now let me just run it to check. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. It is not so fast, but 1 second is still okay, at least for Leetcode. Yeah. Now let's analyze the time complexity. So we're gonna check this number 10 to the power of 9 as k, and the length of the nums is n. So the time complexity is n log k. Thank you for watching. See you next time.